So in this video, we're looking at part 3 of the Unit 1 review, which would be the back of your page. And that begins with problem number 11. So on problem number 11, it asks us to find the domain and range of the function represented below. Well, that's easy enough since this is a discrete function. We can just list the domain values. Remember that domain is a set, so we need to include our braces, and we just list these from least to greatest, which is actually how they are written in the table for us, which is nice. Our range values are our y, so they too are already in numerical order from the table, so that makes life much simpler. So here we have our domain of -5, -2, 1, and 4, a list of just our x values in set notation. Here we have our range in set notation, listing them also in order from left to right. Okay, on number 12, it says, what is the range of the following function? So when we are dealing with range, we are looking at y. Y runs up and down. Because it runs up and down, it might have some limitations on it, and those limitations are what we call our floor and our ceiling. Our floor is how low we can go, so we're just going to draw a line across at the bottom part of the graph as low as it goes, and then we'll also draw a ceiling. We got to be careful here because this is an open circle here, but here's our ceiling going across there when y is equal to 0. Down here at the bottom, y's lowest value is -4, and we get all of our values in between there. So what I have is a lowest value of -4, y is in the middle, upper value of 0. Now these are both closed, so that means -4 is included. Now up here we have an open circle, which means that that would not be included. However, over here where this curve comes up, it actually hits at 0 as well, so it is included there. So it will be included in your final answer. So G is not correct because of the X. That means it's a domain. H is also a domain. And J doesn't give us our -4 to 0, but F does. And just as a note, if we were doing the range, you'd have a -3 here, but it would not include, domain here. If we were doing domain, the -3 would not be included, so you would have a situation like this with just strictly less than. Now it goes beyond 0 and over here to 1, so that would be H would actually be your domain. So this one is your domain. So we found our range here, our domain there. These other two are just there to try to confuse you. But you won't be confused and you'll do just fine. Okay, number 13 doesn't really require any math. We have to actually think about what they're asking us. So we have this function, y equals 1.5 plus 0.35x, and it represents the price, y, for a taxi ride of x miles. So if we're traveling this many miles, we can pay this much per mile plus some more money. It says, which of the following is not a reasonable domain value for this function? Well, these are miles. You could go 17 miles. You could go 35 miles. You could go 25 miles. But you can't go -20 miles. Your miles have to be positive. So this would be the one that is not a reasonable value for this function. Number 14, which of the following relations is a function? So we just have to circle all that are. So here we have an x value of 0, 1, and 2. So this one is a function. This, the x value of 0 repeats, so this one is not, because our x value repeats. Here in number 3 we have a 0, a 1, and a 1. Again, this is not a function because we have x values repeating. We can't have that, not be a function. And here we have 0, -1, -2. All those x's are different. So this one is a function. So we actually have two choices, Roman numeral 1 and Roman numeral 4. So we had two options on that one. Okay, last two. On problem number 15, they're asking us which of these graphs is a function, which represents y as a function of x. So to test for functionality, remember we do our vertical line test. So I drew a vertical line through here, so this one is not a function. And here, no matter where I draw a vertical line, it's only ever going to hit the graph once. So this one is, because this one failed the vertical line test. This one passed the vertical line test. So graph 2 is a function. So our answer choice A says both of them are functions. Well, no, because one's not. Just graph 1, well, no, because one's not a function. Graph 2, yes, it's the only one. And since this says neither graph, well, no, this one is, so it's choice C. Now, in problem 16, you were supposed to simply create your own visual for each of these conditions. So here I've created some for you. I needed a discrete graph that is a function. So notice that none of the x values repeat. But in this one, I've got x values repeating all over the place. So this one's not a function. It may be discrete, but it's not a function. Okay, so a table that's a function. All my x's are different, and here's our y values. Over here, I have a 1 that repeats. 1 is trying to go to 4 and it's trying to go to 6. It can't do that, so this one is not a function. For a continuous graph, remember that's where everything is connected. So here I have my x and y axis. I just drew a little curve in there, and it would pass the vertical line test, so it's a function. For this one, I have my y axis and my x axis, and I drew here, and if I drew a vertical line through there, you would see that this is not a function because it fails the vertical line test because it crosses the function twice. Then they asked us to also do a mapping. This is where you have the two little ovals and you put stuff in them. This is your input and your output, or your x and your y. And in this case, I have 1 going to 7, 2 goes to 8, and 3 goes to 8. And remember that that's a function because these two x's can go to the same place. So everybody can, in a classroom, everybody's in the same place. But you can't be in 3 different places at the same time. So this mapping is saying that this poor one here is trying to go to 2 and to 3 and to 4, and he can't do that. He can't be in more than one place at a time. So this is not a function. So that is the rest of the review, 11 through 16. And I hope that you do well on your test on Tuesday.